Welcome everyone. We present TRAINMAN MAGOS, one of the Trinity use case demonstration series. TRAINMAN MAGOS is a finger tracking based solution which uses a sensorized glove to gather hand movements and translates them into a tangible set of instructions and trajectories to fit a combination of a robot and a gripper. TRAINMAN MAGOS decreases the development time of robotic trajectories and gripping strategies in high dexterity implementations. In this case, this solution has been applied on an automotive glass door assembly operation. TRAINMAN MAGOS has been developed by two partners, Quanta and Qualia and CTAC. Quanta and Qualia is an SME located in Athens, Greece. The other partner is CTAC, the Automotive Technology Center of Galicia, a research center located in Oporriño, Galicia, northwest Spain. Quanta and Qualia, a multidisciplinary team, has participated in many European projects, being its main product the MAGOS platform, which consists in a sensorized haptic glove which provides finger tracking with up to 22 degrees of freedom, as well as orientation and indoor localization, which makes it useful for many applications. On the other hand, CTAC was created in 2002 and it is a private non-profit R&D technological center devoted to support the automotive industry in its research, development and innovation needs. Having more than 800 people working, it has also collaborated in more than 50 European Union research and development projects. TRAINMAN MAGOS aims to revolutionize the programming of robotic systems for manufacturing and other activities, which traditionally need expert human intervention, especially in manipulating fragile parts or while assembling components which demand high dexterity. An example of a high dexterity process operation in the automotive industry is the assembly of a car window glass in a car door, which was the one selected to validate the TRAINMAN MAGOS solution. The architecture of TRAINMAN MAGOS is divided into three main stages: training, pre-processing, and execution. To validate the solution in the selected use case, first, requirements and necessary parameters have been identified, such as gripper and robot selection, data acquisition methods, among others. In our validation case, the chosen gripper was the three-finger robotic gripper mounted on a KUKA Iowa. The aim of the validation was replicating and then measuring the subtask of placing the glass into the car door. First, we register the movements of a human operator wearing the sensorized glove doing this task, so that we were afterwards able to reproduce these movements using the robot and gripper set. We have obtained three important results. Developing time of robot programming is dramatically decreased because TRAINMAN MAGOS provides a draft trajectory which can be refined by a robotic technician. Commissioning time of the robotic application is also decreased, since the time spent by the robotic technician making fine adjustments is reduced due to the high quality of the draft trajectory provided by the glove. Commissioning expenses are decreased because using the glove there are less possibilities of making damages than programming the path by the technician from scratch. In addition, we have to say that expert knowledge, usually confined in the hands of a skilled operator, can be stored and exploited by the company. Automating high dexterity operations is a way of improving operators' well-being due to the fact that repetitive high-demanding tasks are reduced, so the operator can use his or her time in more added-value activities. The main quantitative results from MAGOS are: TRAINMAN MAGOS has been presented in 6 pitching events to a large variety of stakeholders. We have measured a 70% of average increase in productivity for technology adopters following demonstration experiments by decreasing the complexity of trajectories programming time. We have estimated in 20% the increase in company production due to the demonstration actions by decreasing the complexity of trajectories programming time. We have contacted 15 companies in order to start new businesses and related R&D actions. The project has reached TRL 7 as expected, meaning a system prototype demonstration in operational environment. We have measured in at least 20% the percentage increase in process quality for zero-defect products. The contribution of TRAINMAN MAGOS to Agile manufacturing can be summarized in 3 points. Robot programming is faster, since TRAINMAN MAGOS provides a draft path which can be refined by a robotic technician. commissioning time of the robotic application is also decreased, since time spent by the robotic technician making the fine adjustments is reduced up to 20% due to the high quality of the draft path provided by the glove. And commissioning expenses are also decreased, because using the glove there are less possibilities of making damages, in our case on the sidecar door glass, compared to programming the path by the technician from scratch. Other applications in which TRAINMAN MAGOS can be also used are assembly learning. That means using the sensorized glove to obtain information on the execution of an operation at the hands of an expert operator. Therefore, expert operators' know-how is safeguarded, and it would consist in performing a 3D execution of a particular assembly work spot by an expert operator and then showing it to operators in apprenticeship. Another application for using the TRAINMAN MAGOS solution is Ergonomics, using the sensorized glove for workplace ergonomics studies. Thus, the glove could be used to validate ergonomic workstations. In addition, it would be helpful to design products so that it could be checked if they are ergonomic or they are located in an ergonomic position. For example, checking a steering wheel, the use of a car radio, or the handbrake. We want to thank Trinity's board, from technical to administrative assistance, and suggestions about communication and dissemination activities. And finally, if you find TRAINMAN MAGOS interesting and you would like to get more information, in the following links you will get a more detailed description about our solution. You can also contact us in the emails below. Thank you for your time.